Right. Earlier in our class, we saw implementing and verifying EIGRP. We implemented EIGRP and we were able to see the roots. We verified it. We did it with 3 routers. We used wildcard mask to filter some routes. It was so easy for us to filter because we got wildcard mask support. Wildcard mask which specifies how many bits in the address need to match. And this similar thing we did. Now today we are learning something called default network command for EIGRP. Concept is easy, but there's little trick in here. When you do the lab, sometime you will feel you will not see result immediately unless you understand this concept very well. I repeat,
Okay.
this is easy concept, but when you do the lab, sometime result won't come immediately because there will be slight mistake, small mistake you might have done. There are chances for us to do those mistakes. So let's see what it is.
Okay.
Assume we got many routers, not just two. Here it looks like just two. Assume you got many routers inside your autonomous system. Let's say your autonomous system is 100. Okay, here, this is 100 autonomous system. 10.1 to 10.64. So you got 64 network. So many routers are there inside. Because it is cloud, don't think, it is external. This is internal. See, external is here. Internet is here. So the big red color round is your autonomous system. Now, let's say in this autonomous system you got 20 routers. You got 20 routers. Now, if this 20 routers wants to forward the packet to internet, where it should forward? Tell me. If this 20 routers needs to go online to the internet, where it should forward the packet? To all internet networks.
Are you asking me?
Yes,
Okay, I will forward it through that interface that going to the external cloud.
exactly. So any internet destination, you will forward the packet to that serial wire that connects to the external internet autonomous system, external AS. For that, you will use what route? In all 20 routers, what route you will use to go there? In the real world, you will not be learning the entire internet network because it will be millions. In your routing table B or in A or in any of these 20 routers, you won't see any detailed routes to go to Yahoo, Facebook, all the stuff. But you will be using something called what? Default route, right? We'll use default route. Yes or no?
Right, right.
Huh. So now writing default route on all 20 router is difficult for us. Why it is difficult?
Right.
Why it is difficult? Because if any change need to be done, again you need to go and change on all 20 devices. For example, the next stop changes, something like that. So instead of manually statically writing a default route, you can make EIGRP to advertise a default route for you into all these 20 routers. Instead of we writing manually default routes like 0.0.0.0, go to next router and next router till you reach router 5, router A, you'll be saying default route and then next router. If you have a router here, next router. Instead of writing like this, we can make use of EIGRP to advertise default route. Yes, EIGRP can advertise default route. See, when you write a default route in all this router, you will say 0.0.0.0, go to next router, next router, next router, next router. What if this fails here? All the default routes that you have written on all these routers are going to forward the packet up to router A, and router A will drop it. You see, your default route that you wrote is useless if this link goes down. Unnecessarily packet comes all the way here and get dropped because the link failure. But when I use EIGRP to advertise a default route, I don't need to worry about that. If this link fails, the default routes that was given by EIGRP will be removed immediately on all the routers. You understood?
Yes.
The default route that was praise the Lord. The default route that is given by EIGRP to every inside router will be removed if that red serial wire connecting the external goes down. So your packets will not be unnecessarily coming down to router A and get robbed. That's the power of routing protocol. They dynamically do this convergence. Right? So let's learn how to do this. You see, first of all, we need to define this network, which is external, as a default route. Forget about this one. I'll come to this one later. This is simple advertisement that which we usually do. Don't get into that now. You see, this is the network of ISP. If you go to ISP, ISP will take care of your packet that is That's the default network for us, ISP's network. So you need to define that first. And then router A should have a static route. Only router A should have a static route to this ISP. This is the IP address of this router here, 172.31.1.1. See, when you do this thing correctly, you will not you will not face any mistake. You need to have a static route to your ISP from router A, and then you advertise this network that is connected to the ISP. This is the network. 172.31 is running here. You advertise it in EIGRP. And you see this network will run EIGRP here. So when you do this, what happens? You see the static route. And that network is a network which is defined as a default route. So EIGRP will also know that I'm advertising a default route. You see, this is a default network. I'm advertising the route of default network, and this is the route. I'm advertising it. Router A knows that. Router A, EIGRP in router A knows that I'm advertising a default route. So what it does, usually it advertises D with the ID D. D means dual algorithm. This time it has got star on it because it knows that I'm advertising a default network, not simple route. I'm advertising a route which is a default network. You understand? Usually we will have
Yes, 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 sir.
yeah. Usually we will have star for default. Now EIGRP knows I'm advertising a network which is a default network to everyone. So this router, if it wants to go to Yahoo, it will use this route. If it wants to go to some new website which was launched yesterday, glady.com, it will use this route and go to the edge, and edge will forward it to the internet. This is what IP default network command for EIGRP. Please ask me a question. If you have any question, please ask me a question.
No, I don't have a question right now.
Okay. Okay. Now this one you can try by your own if you are fully convinced that if you'll do it, it will work. Otherwise, I can also do it now. Which one you want? You want to try or you want me to demonstrate?
Let me try it because what's going to happen, you're going to upload a video and I will try it.
All right.
And then if I have a question, when I come back tomorrow, I will ask.
That's a nice
But are we,
idea.
okay.
Though, it is looking like easy. If you don't do these things proper, you will face challenges. What? You need to have a static route for the default network, and that needs to be advertised in EIGR. That's all. These three things proper. And I'll also give you a link of early class where I have demonstrated this. So after IP default network command, it's nothing in this chapter. Here they are showing basic configuration between two routers, some example configurations. Now verification, you can type show IP EIGRP neighbor to see the neighbor and the interface via which the neighbor is connected. This host, H means host, this host is the zeroth neighbor. Zeroth neighbor, this one, then zeroth neighbor. And EIGRP send a hello packet. EIGRP sends hello packet every 5 seconds. And the hold time is 15 seconds. So the countdown will be 15, 14, 13, 12, 11, and then see already 5 seconds have gone. And then the hello packet from the neighbor will come. That will make 10 here, and then again 15 here. So it won't go less than 10 if hello is coming right on time every 5 seconds. That's the whole time. And it shows how long the neighbor is up. And this is smooth round trip time. Smooth round trip time in milliseconds. For this two to send and receive packet, smooth round trip, it takes 10 milliseconds. This is also something round trip, or not so important, but this is also something related to that. Maybe this is something maximum. This is the minimum. These are all sequence number, count, not necessary. So what is more important here is the whole time. I always come here and verify whether the whole time is 10 or in between 10 to 15. If it goes less than that, then it is not getting a hello packet. It will disappear. This is one of the verification commands. Show IP IGRP neighbor. Show IP root is a normal routing table like this. It will show you connected as well as EIGRP. EIGRP is D because dual algorithm is in use. But if you want to filter one and show only the EIGRP routes, then you add EIGRP keyword to it. You will see only EIGRP route. Show IP protocol will show all the routing protocols that you have enabled in this router. But currently we have EIGRP only, so you can see only EIGRP's output. The EIGRP is running in autonomous system 100, and these are the metrics, 5 K values. But if you notice here, only bandwidth and delay, K1 and K3 is 1. All other are multiplied by 0. Anything multiplied by 0 is 0. Bandwidth is multiplied by 1, delay is multiplied by 1, which means they both are considered slowest link bandwidth plus sum of delay, you remember. But this one, K2 is load. It is not considered. If load is 10 and you multiply 10 by 0, what is that answer? 0. Since you don't like to consider load. Maximum hop. Yes. EIGRP is not a distance vector protocol, but still, there's a limitation. EIGRP will be effective only if you have less than 100 hops in your environment because it cannot tolerate more networks, more routers, more networks. It cannot handle much. But if you want to increase, you can increase up to 255. That's the max, not more than that. You don't have such a limitation in OSPF. Here, the maximum within an autonomous system recommended is only 100. Variance meaning only best route means equal cost load balancing. We'll talk about that in the next chapter. But if you change this, you can also have unequal cost load balancing. The default is only equal cost load balancing. It will advertise, it will redistribute the routes of only EIGRP 100. Alright, these timers are all not needed and some are omitted. Okay, the maximum path, if you have multiple paths and if all have got same cost, 4 only can be used, any 4. These are the networks that are running, and this is the next hop router. Administrative distance of EIGRP is 90. What is the administrative distance of RIP? Correct, 120.
120.
Administrative distance of EIGRP is 90. Now there is also another administrative distance for EIGRP, which is 170, which is nothing but external routes or redistributed routes. We'll do that later in coming chapters. There's another verification command. Show IP EIGRP interfaces. It shows all those interfaces on which EIGRP is running. For example, here you're running 172.16 and 192.168. So these two are in these two interfaces. Show IP EIGRP topology. We'll show you topology table. This P here means passive, means good. A is not good. Passive is good. Active is not good. Active means it is searching actively for the route. P means well settled routes. More about this is coming in coming chapters. EIGRP sends hello packets, update packets, query packets, reply packet, and acknowledgement packet, which we saw earlier in the previous chapter. So if you wish to see how many hello packets, how many update packets sent and received, you can use this command. SIA means struck inactive. We'll come to these things later. So this chapter was teaching us thoroughly how to configure and verify EIGRP. Are you confident with this chapter?
Yes, I'm pretty confident. Just that I'm supposed to do the lab, which I'm confident I can also do the lab, but I want to do it just to solidify my knowledge. So I do that maybe tomorrow morning or so forth.
Okay. Do this and then give me your advanced EIGRP. As a first advanced feature, we are going to see the summarization, which is very unique summarization in EIGRP. We got two types of summarization in EIGRP. One, the global summarization, which is also called as auto summarization. The other one is the manual summarization, which is under the interface level. I repeat. We got two types of summarization, the global summarization and the manual summarization. In another word, default summarization or interface level summarization. We're going to see when to use which summarization. The purpose of summarization is to keep your routing table smaller. When you keep your routing table smaller, if the routing table is smaller here, the roots of the routing table will be advertised, so the updates will also be smaller. If your routing table is big, then advertisement is also going to be big. Update will also be big. So smaller the routing table, smaller the update, less the bandwidth consumed by the update, less the CPU consumed on the receiving router. Summarization is good. You can enable automatic summarization if you want in the newer version. In the older version, it is enabled already by default. You might have seen every time when someone configures EIGRP, they'll say no auto summary, meaning they are canceling the automatic summarization. Putting no, you are canceling this automatic summarization. In older version, it was enabled by default, so you used to cancel. In the newer version, if you wish to have automatic summarization, you can enable it. By default, it is not enabled. In the newer version, by default, summarization is not enabled. I'm going to show you this first. This is not a new lab for us. We have used this lab in the previous scenarios, basic EIGRP configuration. Now, I'm going to change the subnets to maybe 172.16.12.0/24. And here I'm going to say 192. All right, so that's the change. And I'm going to show you the summarization for these networks only. This is the focus. We're going to see how do we receive these four routes in R4 and R3, so R2 and R3. I'm going to remove EIGRP, which is enabled earlier. I'm going to do fresh on all the routers so that you will not have any confusion in understanding. All right. So I remember earlier we were running EIGRP 200. I'm saying no router EIGRP 200. By putting no, I'm canceling EIGRP. Now if I check, I should not see show IP protocol. I should not see any routing protocol. I don't see it. And on the interface G3/0, I would like to change the IP address to 172.16.12.1. Next. On the interface G4/0, I would like to make this as an IP as 192.168.0.1, 255.255.255.0. Verify. Show IP route. As of now, I don't have anything from outside. I just got the connected. Next. Going to router 2. Don't worry about this L. L means the address on the link. On loopback 1, this is the network and this is the exact IP address.
Okay.
So I'm going to do similar configuration on other two routers. First, I'll go there, remove the EIGRP, which we did earlier. No router EIGRP 200. Hostname router 2. Then on the interface G3/0, IP address will be 172.16.12.2. Show IP protocol. I want to check whether there is any protocol. No protocol. One more router to start summarization. One more router. No router EIGRP 200. Interface name is 30/3/0. Interface G3/0. Two five five 25250. So show IP interface brief. I should see the IP address. Please. Now when I connect the directly connected IP address, I should be able to ping 192.168.0.1 must ping. Likewise from router 2, I should ping 172.16.12.1 because it's directly connected. What is next? EIGRP. Shall we begin EIGRP? Are you ready now? The summarization?
Yes, I am.
Okay. What I want to show you here is very important. We are running newer version of EIGRP where summarization is not enabled by default. In the older version, it was enabled. Because summarization is good, it is going to reduce the size of the routing table, size of the updates. They made it default. Summarization, globally, they enabled it as default. But later they realized that, oh no, because we are doing summarization, sometime in a large network when we have a lot of subnets, there is some confusion happening. And everyone is saying no auto summary, no auto summary. So everyone, you might have seen, everyone will say no auto summary whenever they configure EIGR. So Cisco thought, okay, because everyone is doing that cancellation of the default what we are doing, let us also cancel it instead of keeping it. So they made it as disabled now. That I want to show you first. So I'm going to run EIGRP on all three routers starting from router 2. Router EIGRP 200, network 2, network 172. I did not say no auto summary, you see. I did not say. Now, let's verify. Show IP, EIGRP, or show IP protocol will be the best command. You can see here automatic summarization is disabled. But what you saw in the presentation is what did we see here? We saw that auto summarization is occurring by default, means it's enabled by default. Yes, older version it was enabled by default. Yeah. In the newer version, no, we don't. Okay, so that is about automatic summarization.
Okay.
Now let's finish configuring the other routers. I want to do router 3 and then I'll go to router 1. Router EIGRP 200. Sorry. Then I'll say network 3. Network done. Now let's move on to router 1. Router EIGRP 200. Network 10 means all the 10 network, 10 subnets. Network 172.16. Network 192.168.0.0. Right, we got two neighbors. Let us verify this. First of all, I would like to say show IP EIGRP interfaces. I would like to show you all those interfaces that runs EIGRP. I'm expecting 4 plus 2, 4 lubats and 2 physical. Yes. These are all the interfaces that are part of AIGRP. Next, show IP AIGRP neighbor. And here we see there are two neighbors. One is 192.168.0.3. You see that number 3 means router 3. And number 2 means router 2. And router 3 is connected via 4/0. Which came first, it's router 2 came first. How do I know? You see, number 0 is given to router 2. That's the 0th neighbor. Even you can see in the timing, uptime. This has got more seconds than the other one. And if you go up, you can see that I was configuring 172 first. So EIGRP with router 2 came first. That's what you see here, 0th neighbor. This is the next first neighbor. So after router 2, router 3 became neighbor. Yeah, like 7 seconds different. 7 seconds. In 7 seconds, the second. If you see the timer here, it won't go less than 10. 12, 11, 14 again. After 11, it has gone to 14. What does that mean? It means that hello packets are coming on time. Every 5 seconds, hello packets will come. Yeah. So it's a countdown timer. If you notice here, for every second the hello packets are getting incremented, the timer is getting decremented. Sorry. Next. Manual summarization and auto summarization. Auto summarization is disabled. If you enable, what will happen? Let's see. Before I enable that, I would like to show you the routing table in router 2. Show IP route EIGRP. I'm not seeing any summarized route here. The detailed routes are coming from router 1.
I do have a question.
Yes, please.
Right. The advertised distance for the loopbox and the advertised distance for that 192. Why is it so low for the 192 and the advertised distance for the loopbox? Why are they not the same?
See, it cannot be seen. The reason is this 192 is physical. Router 2 learns about 192 via router 1. It also learns about loopback via router 1. But the loopback, which is behind R1, is not a physical, right? It's loopback. Always for loopback, the bandwidth will be very low because it's loopback. There is no need for bandwidth. It's not physical. So that's just a dummy bandwidth. And delay will be very high.
Okay, now I get it.
So R1 gives a big number for that. Whereas 192.168 is physically connected to R1. Yeah, same answer. R3 is loopback. So the metric there is very high because the bandwidth and the delay are very poor. Loopback is always going to have poor metrics. The reason is loopbacks are only for testing. We should not take that as serious path. If there is an option whether to choose loopback or physical, it should be only physical. That's why loopbacks are designed with bad metrics. Okay, now coming to the story. The summarization is not done for networks. As a result, you can see precise routes. 333, 10.1.1, 10.2.2, 10.33, 10.44. You see all precise routes. None of these are summarized. Now I'm going to R1 to make R1 auto summarize or a global summarize. Before that, I want to show you one more time the routing table in R1. I repeat, I want to show you the routing table in R1. Show IP route EIGRP. In R1, you see only two routes. But when I enable summarization, you will see one more or more than one. I'll say router EIGRP 200 auto summary. You see, show IP show IP protocol. You can see that summarization is enabled by me now. And it clearly shows you the information right here. It says, hey, I'm summarizing this network before sending it to G3/0. And I'm summarizing this network before sending to router 3. This is router 3. And I'm summarizing this network before sending to both router 2 and router 3. They are connected via this way. And it also puts the summary metric. And I want to show you in the routing table, show IP route EIGRP. Look at this. This is what I was talking about earlier. When I showed you earlier, you saw only 2 routes. Now you will also see some summary routes pointing towards null. This is very important. What does router 1 says? Router 1 says, hey, if I need to advertise summary route, anything that I want to summarize, if I want to advertise something, it should be there in the routing table. If it is not in the routing table, how will I advertise? See, in the routing table, it was not there earlier. We are asking EIGRP to summarize before sending. But to send, what is the basic criteria? The route need to be in the routing table. If not, it cannot send the routes. Now, if you are expecting a default route to be advertised, the default route needs to be there in the routing table. It is there. And it is pointing towards null interface. Why? Because this 10 belongs to all loopbacks, all 4 loopbacks, not just one loopback. So there should be one dummy interface now. On behalf of all 4, this is summarized. So it cannot point to loopback 0 or loopback 1 or loopback 2. So to avoid loop, it is pointing towards null. If it points towards loopback 1, and the packet to loopback 3 will go to loopback 1, and loopback 1 will send to loopback 2, and there will be a loop. So whenever you summarize, the summary route will appear. All the 10 are summarized like this. The summary route will appear with pointing towards null 0 on the routing table. Now, if I go to router 2, earlier I had.
Wait, one moment. Okay, all right, back right here. What I've noticed is that 172 also got summarized and get pointed to a null
Yeah,
0, but I don't see anything for 192. What happened to 192? Why there's no
because
summary to 192?
192, you cannot summarize this 24 anymore. 192, what is the default mask?
Okay, got it.
Okay. Now, if you go now to router 2, earlier we were having detailed route, but because I enabled summarization on the router 1, resynchronization happened, and now the routing table changed. It is changed with the summary. Now it's very small. All those precise routes gone. But still you will be able to ping 10, 4, 4, 1. Very well, because you got a default route. 1 minute. I think address given in R1 is different. Show IP interface brief. It's not 441, it's 444. Yeah. So by using the default route, you are able to ping. Not default route, sorry. Default route is the previous chapter. The summarized route. Now, question. To achieve this, did summarization enable on router 2? No. I did not enable summarization in router 2 because I'm not focusing on the network advertised from router 2. So it is only router 1 where we need to enable it. I say auto summary there. Because by default, see in router 2, show IP protocol, It is disabled. Only on router 1 I have enabled. Show IP protocol. I've enabled. So summarization, global level summarization. Global level summarization is what we have seen so far. Now, going back to the presentation, I would like to go back to the presentation because I need to teach something. Then I'll take you to the lab again. Did you understand this page well? The older version, the newer version differences?
Oh, yes, sir.
Good. Let's go to the next. AGRP route summarization manual. What is manual? It's not auto. What is manual? It is talking about the interface level summarization. Interface level summarization. Why do we need it? Taking you back to the routers. You see, after I enable summarization globally, both router 2 and router 3, you see router 3? Show IP route or show IP route EIGRP. Both router 2 and router 3 has got summary route, isn't it?
Yes, sir.
For some reason, I don't want summarized route in R3. You understand what I'm saying? I do not want to see summary route. I want detailed route. On R3, I want detailed route, but in R2, summary route. You understood? In R2,
Yes, sir.
I want to see this. In R2, I want to see like this. In R2. In R3, I don't want to see like this. I want to see detailed 10.1, 10.2, 10.3 like that. I want to see detailed in R3. It should be detailed. How you achieve that? Let's go and do cancellation of summarization in R1 first. I'll go here and say router EIGRP 200. No auto summary. I cancelled. I enabled it earlier. Now I cancelled it. After I cancel, the resync happens. Now both the routers are going to, see, it is disabled. Now both the routers are going to get detailed routes. I'm happy with this on R3 because on R3 this is what I want to see. But in R2, I'm not happy. Why? Why? Why I'm not happy with this routing table? What did we discuss?
Because it is showing
Detailed
route and you just only want summary route.
Yeah. I want to see only the summary route on route 2. But what I see is detailed here. So what you can do now, you can go to this interface. Look at this one, G3/0 that connects to router 2. Go to that particular interface. And say this command, IP summary address for EIGRP 200. Don't forget, you need to mention this autonomous system number. Under the interface only you should configure. And make sure globally you disable, very important. If not, you will not see the desired result. Why I disable globally? Because on R3 I don't want. So if I globally have enabled, then problem. I globally disabled, and I'm going to enable summarization only on that interface where R2 is connected. So I say IP summary address EIGRP 200. And how do you want to summarize? I want to summarize all the 10 like this. Anything that starts with 10 should be summarized like this. See, the resync happens only with router 2, not with router 3, because we have done it on G3/0. Does it make sense?
Yes,
All
sir.
right. Now, if you go to the routing table, you will still have a default summarized route pointing towards null. Show IP route edge. You see, without having this route, you cannot advertise. You need to have this route in the routing table. That's why you see this. And it is advertised only to router 2. How do I know? Here also you can see. Only on G3/0 it is summarizing. Address summarization happens only on this interface, not on any other interface. This is what called as manual summarization. Now let's go to router 2 and verify that. Earlier it was detailed, but now it is summarized here. In router 2 it is summarized, and you still will be able to ping this. And on router 3 you will still have the default route. Yeah. Now let's go back to our presentation. Did you understand? Now quickly let's read this. You will understand this now, all the sentences. Summarization is configurable on per interface basis in any router within a network. As summarization is configured on an interface, the router immediately creates a route pointing towards null 0 to prevent loop. Now, when will be the summarization goes away? I repeat, with the topology and with the router. You see, we saw in the routing table, there is a summary route. When will this disappear? If I shut down all these 4 ports, this will disappear. You agree with me? If I shut down 2 of this,
Yes, yes.
if I shut down 2 of this, will it go? No,
No.
because it's the summary of all 4. That is what said here. When the last specific route of the summary goes away, only then the summary will be deleted. Last means all loopback should be shut down in our case, in our example. Now, what is the metric? The metric, if you have a different metric, see in our case, all 4 are loopbacks. In our case, all these 4 are loopback. But in the real world, this may be one LAN, this may be another LAN, this may be another LAN, another LAN. Each LAN may have different metric. Now, which metric will be given to the summary route? Among these 4, the one which is minimum, the metric minimum. The minimum metric of a specific route is used as the metric of the summary route. If you see here the routing table, it has got the summary route pointing towards null, and for this a metric is given that you can see on router 2. This is the metric given, and this is the minimum metric on the loopback interface. Usually loopback interface will have similar metric on all 4, but in the real world, if you have physical interfaces, different physical interfaces, the minimum among those 4 physical interface is taken and sent as the metric for the summary route. Is this clear? Is this clear? This page is clear for you?
Yes, sir.
Right. Now this is what we did so far. Order summary, turning on, turning off, and then we went under the interface and we configured the summary address command. We generated a summary route only for one router, which is R2, like this. We did this similar lab. Are you confident on the summarization
Yes,
in
sir.
EIGRP? Do you have that confident?
Yes, I can do it. I think I'm sure I can do it.
Okay. So next is about EIGRP load balancing. At least we should stop